Here's a nice list of items that we should keep in mind while we are troubleshooting Virtual Router Redundancy Protocol, or VRRP for short. First one on our list is timers. We have to make sure that the timers match with VRRP. This is unlike HSRP. With HSRP, the timers did not have to match, but with VRRP, they do. Because if they don't match, the virtual routers within that group technically don't see each other, meaning they don't classify the other routers as being part of that same group because the timers don't match. As a result, they technically don't see each other, and as a result, they pretty much all promote themselves to the virtual router master, meaning that they're all forwarding traffic for that exact same group. And we only want one forwarder and the rest as being backups. So the timers have to match to make this work as we intend it to. Group numbers have to match as well. So if we are configuring VRRP group 20 on one device, it's going to have to be VRRP group 20 on the other devices, so that way they're all within that exact same VRRP group. If there's any discrepancy between the group number, then they are technically in different groups and therefore will be forwarding traffic for that particular group that they have been configured for. The virtual IP address is very important. Now, that virtual IP address in a VRRP group can be an IP address that is on an interface on that router, or it could be one that is not being used at all. However, regardless of what it is, all of the routers have to agree on that particular virtual IP address, or they will be the forwarder for different IP addresses. And remember, our clients are going to be configured with an IP address as their default gateway, and it's this virtual IP address that they're configured with as their default gateway. So if you configure it as one value and a certain router is using that in the group and another router is using a different address in the group, well then if a failure happens, the clients are still pointing to the device that failed. So it's really important that the virtual IP address is correct throughout the group and on the clients. Authentication ensures that we're only going to be listening to those VRRP messages from authentic devices. This ensures that we don't have rogue devices becoming the virtual router master within the environment, and then all of a sudden all our traffic's being captured as it's going through this rogue router that's acting as the default gateway. So if we want authentication to be successful, the parameters have to match perfectly. If they don't, then we're going to have routers in different groups within our environment. Preemption here states that it's misconfigured. How is that different than being enabled or not? Well, by default, preemption is enabled. This is completely different than HSRP, where it's disabled by default. So since it's enabled by default, this is not really going to be an issue for you unless somebody manually disables it on you. Client configured with the incorrect IP address, something we really have to be aware of. That client, it needs an IP address specified as its default gateway. If that is not the IP address that is being used by the VRRP group as the virtual IP address, then our VRRP feature solution is not going to work as we intended to. And we have object tracking available to VRRP. With HSRP, you have interface and object tracking, while with VRRP, you just have object tracking. So you'll have some type of object that is being tracked, and then if that object is down, then you can have your priority dynamically decreased to a value that makes it no longer the preferred device to be the virtual router master, and then the backup device can take over and start forwarding traffic. So here's a sample configuration of VRRP. We have interface VLAN 10 that's been configured with an IP address. We have our VRRP commands being utilized to configure our group, and this is group 10. Very important you get the group number accurate with all your configurations, because you specify group 10 here, then group 11 here. Oops, you just configured group 11 with priority 110, meaning group 10 still has the default of 100. So priority still 100 with VRRP. There's the virtual IP address listed, so that's going to have to be accurate amongst all the devices. Now, the virtual IP, it can be, I repeat, it can be the IP address configured on one of the interfaces, on one of the routers that's going to be in the group. So it could be 10112. And what that means is that this device with the IP address of 10112 will automatically become the virtual router master. If not, it's based on an election process with this particular priority. Higher priority wins, default being 100. Preemption is enabled by default. Here's some authentication parameters for VRRP, and then we have our object tracking that we've configured here, where we're tracking object 90, which is a particular interface. We're keeping a track of its status. So is it up? Is it down? And if it happens to go down, we're going to decrement the priority by 20. So 110 minus 20 is 90. And if our backup router has a priority greater than 90 and preemption is enabled by default, don't forget, it will automatically take over as the virtual router master. So it's really important that you have the ability to walk through a configuration as such to determine if it is accurate. But it's really, really good as well to have this as a spot the difference. You can compare your VRRP configuration on one device to the VRRP configuration on another device, and you can see where you went wrong. So it's really easy to use spot the difference when troubleshooting VRRP.